When we multiply or divide quantities that are measured, we have to take into consideration the total number of significant figures associated with each quantity. The measured value with fewest significant figures dictates how many total sig figs there will be in our final answer. For example, when we divide 986.72 by 5.12, we count up all the sig figs in each of the numbers we're dividing. 986.72 has 1, 2, 3, 4, 5 sig figs in it. 5.12 has 1, 2, 3. Our final answer can only contain 3 sig figs. When we punch these numbers into a calculator, our calculator result gives us 192.7188. To count off 3 significant digits, we'll notice that since there's a decimal point, we'll start from the left and only use the first 3. 192.7, well, the 1 and the 9 give us 2 significant digits. If we just left the 2 in there, then we're not rounding properly. We need to use the first non-significant digit to tell us whether to round up or stay the same. The first non-significant digit is a 7. This tells us that we round the previous digit up. So our final answer is 193, 3 significant digits rounded properly. When we divide 920.7 by 4.32, again, we count sig figs. 4 sig figs here, 3 here. We'll need 3 in our final answer. Once more, plug this into a calculator, and we end up with 213.125. Here, the 2 and the 1 are the first 2 significant digits we'll keep from the left. The first non-significant digit after our 3 is a 1. That tells us that we round down or stay the same. We'll keep that 3 intact. 213 is the proper answer for this problem. When we multiply 98, which has 2 significant digits, by 0.006, which only has 1 significant digit, we'll just keep 1 significant digit in our final answer. Our calculator result is 0.588. The only way to keep 1 significant digit is to round that first significant digit 5 up. 0.6 is our final answer. In the next problem, where we multiply 45.20, which contains 4 significant digits, by 0.0071, which only has 2 sig figs in it, we'll keep 2 sig figs in our final answer. Rounding to the appropriate number of sig figs, 2, from 0.32092 gives us 0.32. Our final significant digit does not round, it stays the same, because the first non-significant digit after it is 0. Multiply 10 with a decimal point, meaning there are 2 significant digits in it, by 300 with a decimal point, meaning there are 3 significant digits here. We'll keep 2 sig figs at the end. 10 times 300 is 3,000 based on our calculator. How do we make 3,000 show 2 significant digits? Well, that's sort of tricky. It's hard to do that with numbers written like this. Here, a useful trick would be to convert this number to scientific notation. We have an imaginary decimal point at the end of this number. We could move that imaginary decimal point to 1 space just to the right of our leftmost digit. If we do it in such a way that we keep 1 0 after the decimal point, we'd end up with 2 significant digits in this value, 3.0. Then we multiply by 10 to the power that's represented by the skips that we took to get that decimal point to its new location. That's 1, 2, 3 skips. 3.0 times 10 to the third power. This is an appropriate way to write 3,000 with just 2 significant digits. Moving over to the next column, 497.7, 1, 2, 3, 4 significant digits, divided by 3.0 with 2 significant digits, we'll have an answer that's reported to 2 sig figs. Punching it into our calculator, we get 165.9. Only these first 2 digits are significant, the 1 and the 6. But the first non-significant digit is a 5. That means the 6 rounds up. What do we do with that last decimal place to maintain the order of magnitude? To tell us that we're dealing with hundreds and not just 17? Well, we can put a 0 there without any decimal point, and the presence of a decimal point means we start counting from the left. The lack of a decimal point means we'd start counting sig figs from the right. By not placing a decimal point here, the number of significant figures in 170 is 2, because as we count from the right-hand side, we don't start a count on 0. Only the 7 and the 1 are significant. In multiplying 400.20, which has 1, 2, 3, 4, 5 significant digits, by 3.010, which has 4 significant digits, we'll keep 4 sig figs in a final answer. A calculator result is 1,204.60, keeping the first 4 significant digits and rounding the last one up, because the first non-sig fig is 6. We'll end up with a final answer of 1,205. In 0.009430, which has 4 sig figs, multiplied by 4,310.9, which has 5 sig figs, we'll again keep 4 significant digits in our final answer. Multiplying these out and taking a calculator result, we'll have 40.6517. We'll keep the first 4 significant digits. 40.65, this last significant digit, does not round because the number that follows it is 1. Divide 9.0, which has 2 sig figs, by 3.0, which also has 2 sig figs, meaning that our result has 2 sig figs. 9 divided by 3 is 3. To keep 2 significant figures when a calculator is only showing you 1, add a decimal point and zeros at the end. 3.0 contains 2 sig figs. When we divide 10 by 3, where a decimal point follows 10 and we have 2 significant figures, but no decimal point follows 3 and we only have 1 sig fig, we'll only want to keep 1 significant digit in our final answer. Calculator results show us 3.33333 and so on, but if we only want 1 significant digit, we just keep the 3. We don't round it up, because the digit that follows it is